Whenever divers prepare themselves for a diving operation in HMS Challenger's SCC, they hand you a great responsibility. The SCC handling crew is literally their lifeline, and that's why your training is so intensive. This video is designed to give you an overall introduction to the SCC handling system, and with the detailed manual, form a complete training module.
So let's begin at the beginning with the system itself. It's an independent hydraulically powered system that can deploy the SCC to depths of up to 300 meters and then recover it again once the operation's complete. There are many design features to ensure the safety of the SCC and the divers at all times. So we'll be looking at two areas in particular as we see how the system works. And first, redundancy. That's providing backup services so the SCC can be recovered if there's a partial systems failure. It includes alternative drive mechanisms, hydraulic supplies, and the second area is interlocking, the safety devices that stop equipment being operated unless it's safe to do so. Now we'll be looking at redundancy and interlocking in some detail as we go through the video. But first, let's identify the main components of the handling system and their functions.
The sinker weight carries central ballast weights and sheave assemblies. It's deployed on wires which it keeps taut to guide the SCC to the worksite. The weight is stowed on this sinker weight trolley above the moon pool when not in use. And the trolley is retracted by a locally controlled hydraulic cylinder before deployment. The sinker weight winch deploys and recovers the weight driven from the desk in dive control. There are two modes of operation: manual drive for deployment and recovery, and auto tension to compensate for the vessel's motion when the weight's on the seabed. As the sinker weight, or SCC, travel through the moon pool, they're restrained by the cursor, a framework which travels down vertical guides either side of the moon pool. The cursor is raised and lowered by its own winch, driven from the desk in dive control. Again, there's a manual drive mode and a constant tension mode which automatically takes up or pays out wire when the cursor is restraining the sinker weight or SCC.
Then on deck, the SCC itself is stowed on this trolley, which also traverses it from the moon pool to the transfer chamber. Making sure the SCC side trunk is accurately aligned for mating with the transfer chamber spool is the job of 6 of these feet here. They're equally spaced out around the trolley. Hydraulic clamps make sure that the SCC is locked firmly onto those feet. The trolley itself can be driven by either of its 2 motors. There's one on this side, one on the other side, and there's a hand pump here which can be used to release the brake for manual traversing. Maintaining a gas-tight seal between the SCC and the transfer chamber is the role of this split clamp here, which has tapered faces to suit the mating flanges of the SCC and the chamber.
When it comes to raising and lowering the SCC itself, the strain winch has 4 drive motors to do the job. 2 with direct drive onto the drum and 2 with reduction gear drive. Driven from the desk in control, the winch has 2 normal modes of operation. Low speed, using the 2 direct and 1 reduction drive motors to give the power needed to handle the weight of the SCC in air, and high speed, using only the 2 direct drive motors to handle the reduced weight of the SCC in water. The strain winch can also be driven in 2 contingency modes, side A and side B, where each pair of direct and reduction drive motors are supplied from the respective side of the hydraulic system. Because it's so important to be able to recover the SCC, the winch has its own local emergency controls which are purely manual in operation. And the same is also true of the vital umbilical reel winch above.
Under normal operation, it's driven in manual or constant tension modes from dive control using either of its two drive motors. Manual mode is used to pay out or take up any slack umbilical, while constant tension mode automatically raises or renders the winch in line with the SCC movements. The line pull output of the winch is variable and is set at the control desk.
Of course, when it's at its operating depth, the SCC's movement is affected by the motions of the vessel on the surface. To reduce these effects, the handling system incorporates a heave compensator. Powered by a bank of accumulators, this cylinder carries a sliding sheave assembly and acts like a hydraulic spring, paying out or taking up wire as the vessel rises or falls to minimize SCC movement in the water. The hydraulic power source for all these component parts is this SDS power pack on number 4 deck. It's split into two independent sides, A and B, each supplying 226 litres a minute of oil at between 170 and 205 bar pressure. To balance demand in normal operation, various equipment is fed from each side. If one side should fail, the other still run the system at reduced speed, and the SDS system can also be supplied from the aft power pack system that normally powers the A-frame.
As I've said, all the winches and the heave compensator are normally remotely driven from this control desk in dive control. The fascia carries all the necessary controls and indications, while this panel above the desk gives the sinker weight, the strain wire and umbilical deployed. Inside the desk, there's also the programmable controller and relays that work together to provide system management, electrical interlocking and alarm systems. Now, as we've described the components of the system, we've already covered many of the aspects of redundancy that are provided. But before we move on to the way the handling system operates, it's worth summarizing redundancy. Under the heading of hydraulic supplies, all the winches and the heave compensator can be supplied from either side A or side B, with the exception of the strain winch, which uses motors fed only from side A or B. And the SDS system can also be supplied from the aft power pack. Under drive mechanisms and arrangements, remember that the umbilical winch will run on either of its drive motors. The strain winch can use many permutations of its drive motors. And the SCC trolley can run on either of its two drive motors or be manually traversed. Finally, in the event of losing the electrical control system, both the strain and umbilical winches are equipped with manual emergency controls. Now let's put all the components of the handling system into context by watching the various stages of SCC deployment and recovery. Here's the equipment stowed. It is first lowered onto the sinker weight. The two are raised clear of the sinker weight trolley, which is then retracted. When the sinker weight's deployed, the cursor remains at the keel. Then the SCC TC clamp is opened, and the umbilical winch and the heave compensator prepared for trolley travel. The trolley is driven to the transfer chamber and manual locking pins are fitted. The heave compensator is stowed and slack strain wire and umbilical paid out. Then the SCC TC clamp is closed and the clamp's locking gate is closed. At this point, the trunk is pressurized, the divers transferred and the trunk vented again. Next, the cursor's raised to sit on sprags. The SCC TC clamp, locking gate and the clamp itself are opened, while the umbilical winch and heave compensator are prepared for trolley travel. The SCC trolley locking pins are removed. It's driven to the moon pool and pins refitted. Then, with SCC guide wire clamps closed and the side door closed, the cursor's lowered onto the SCC.
With the heave compensator stowed, the SCC trolley clamps are open and the SCC and cursor raised clear of the trolley. Notice how the bump frame drop stage extends and the drop stage locking plates are then fitted. The SCC trolley locking pins are removed and the trolley driven clear of the moon pool, so that the SCC and cursor can be lowered to number 1 deck and the cursor gates closed. The SCC is lowered to the keel in low speed mode, then can be deployed to depth using the high speed mode. Then, if the heave compensator is being deployed, slack umbilical is paid out ready for the operation. Briefly, that covers the actual deployment, and without going into too much detail at this stage, recovery of the SCC is almost the exact reverse process of the operation that we've just seen. More important at this time is to understand the interlocking requirements that the handling system has. That way you'll be aware of the inbuilt safety devices that will freeze the whole system if you try to operate equipment in a way that endangers it or the divers. Now, there are 7 particular areas that we should look at in this respect. First, the SCC-TC clamp can only be operated when the transfer trunk pressure has been fully vented. Second, the umbilical winch can only be driven when the SCC-TC clamp is fully open. Number 3, the SCC trolley can only be driven when the umbilical winch and the heave compensator have been properly arranged for trolley travel. The strain winch can only be operated when the SCC is directly over the moon pool, and the heave compensator can't be opened under power until the SCC is off the trolley. Only when the SCC is at or below keel level can the strain winch be engaged into high speed, and it must be re-engaged into low speed before recovery past that same point. Last but not least, interlocking ensures that equipment can't be over-raised into the gantry.
There are 2 kinds of interlock involved, mechanical and electrical. In a little more detail, let's look at mechanical interlocks and the SCC-TC clamp. Here, a double interlock of 2 operated valves prevents the supply of hydraulic oil to the clamp motor valve and trolley controls, unless they both sense that the transfer trunk pressure is below 10 psi. In addition, there's a mechanical gate to be removed before the clamp can be opened, and that can't happen until the trunk has been vented. Once the clamp is correctly opened, oil flow can progress to the trolley control valves. The final mechanical interlock preventing supply of oil to the trolley is a solenoid valve down here. Now, it'll only be opened when all the following conditions are achieved.
1. This pressure switch confirms that the trunk has been vented. 2. The proximity switch on the clamp frame confirms the clamp is fully open. 3. This pressure switch between the roller-operated valve and solenoid valve senses that the roller valve has been opened by the clamp as it reaches full open position. 4. The heave compensator has been suitably prepared for SCC trolley travel. 5. The umbilical tension is within acceptable limits for trolley travel. 6. The umbilical winch is engaged in constant tension mode, ready for trolley travel. It's complex, but it has to be. And remember, conditions 1 to 5 aren't a requirement for power to the trolley once the SCC has been removed from it, as indicated by the 3 proximity switches. But now let's look at the electrical interlocks in the system. First, control of any equipment will be isolated whenever the emergency stop push button is activated. Now, releasing that emergency stop will allow control of the sinker weight and cursor winches, the only interlock remaining being the over-raise cutout on the cursor winch. If this is activated, power will still be available in the lower direction. Both the umbilical winch and use of the heave compensator, unpowered, will be interlocked unless 3 of the conditions already used in the mechanical interlocking are satisfied. First, the pressure switch sensing transfer trunk gas pressure confirms the trunk has been vented. Secondly, the proximity switch on the clamp frame confirms the clamp is fully open. And thirdly, the pressure switch between the roller-operated and solenoid valves also confirms that the clamp is fully open. You can only admit pressure oil to the heave compensator when these three conditions have been satisfied and the SCC has been removed from the trolley as sensed by the three proximity switches. These same conditions apply to using the strain winch in the low-speed mode with either the SCC confirmed removed from the trolley or the trolley positioned at the moon pool as sensed by the proximity switches. Also, the umbilical winch must be engaged in constant tension mode. It won't be possible to satisfy all the strain winch low-speed requirements when you're preparing the heave compensator for trolley travel. In this case, the interlock override switch can be used. Next, using the strain winch in high-speed mode will only be possible when this strain payout meter shows that the SCC is at or below keel level. And last but not least, you'll lose control of the strain winch as you would with a cursor winch if the top of gantry over-raise proximity switch is activated. Now, I realise that we've covered an awful lot of ground in this one video, but don't forget, everything is repeated in detail in the training manuals. And of course, you can always replay this tape until you're completely familiar with what you've just seen. So, good luck and safe handling on board HMS Challenger.